Hello, my name is Taylor, and my lesson is a grade 1 science lesson focusing on physical sciences and the concept of pushes and pulls. This lesson aligns with the Victorian Curriculum Code VC2 S2U11, which focuses on how pushes and pulls are forces that can change an object's movement or shape, including the strength and direction of the force. The learning intention is we are learning that pushes and pulls are forces that can change how objects move. Students will learn to identify pushes and pulls and describe how the strength and direction of a force can affect movement. The success criteria for the students is that they can identify a push or pull, explain how a force changes an object's movement, and describe whether the force is gentle or strong, which will be assessed through the lesson by teacher observation and questioning, completion of worksheets, and finally by the exit ticket. The lesson begins with a push or pull Simon Says activity where students physically demonstrate different pushes and pulls. This activates prior knowledge and introduces key vocabulary. The main body then consists of 3 activities. Activity 1 being push or pull detective, where students investigate everyday objects such as a toy car, trolley, tennis ball, chair, and a box to identify whether they are being pushed or pulled. Activity 2 is a force challenge. It allows students to investigate how changing the strength of a push affects how far a toy car can travel. Activity 3, Playground Force Detectives, uses photographs of playground equipment. Students identify where pushes and pulls occur and then draw arrows to show the direction and identify whether the force is gentle or strong. For my Microteach demonstration, I will focus on Activity 1, Push or Pull Detective. The teaching strategy I will practice is explicit teaching, supported by teacher modelling and questioning. I will model each force and ask students such as, is this a push or a pull? Was the force gentle or strong? For inclusion, I have a student with low literacy working at a foundation level. I will support this student through visual picture cards, short verbal instructions, teacher modelling, and sentence starters, such as I pushed thee. The student can also demonstrate their understanding verbally through pointing or by physically demonstrating the force rather than completing extensive writing. I will also pair the student with a supportive peer where appropriate. Overall, the lesson provides students with an engaging, hands-on way to explore forces using familiar objects. My Microteach will demonstrate how I use explicit teaching, modelling, and questioning to support students' understanding of pushes and pulls. All right, scientists, today we are going to become force detectives. Can everyone show me your detective eyes? So our job is to investigate some everyday objects and work out whether we push or pull to make them move. Before we start, let's learn 2 important science words. A push is when we move something away from us. Can everyone show me a push? Great, amazing work. And a pull is when we move something towards us. Can everyone show me a pull? Excellent. Our first object is a toy car. How do you think I could make the car move? Let's test it. I used a push and the car moved away from me. Was that a push or a pull? That's right, a push. Now I'm going to try a stronger push. Look, the car travelled further. So what happened when I used a stronger push? That's right, the car moved further and faster. Scientists, this tells us that the strength of a force can affect how an object moves. Now let's investigate this trolley. Do you think I could use a push to move it? Let's see. Yes, I pushed it away from me. But here's our challenge. Can I also use a pull to move the trolley? Yes, I can pull it towards me. So can one object be moved both by a push and a pull? Absolutely. Let's try a gentle push. Amazing. And let's try a stronger push. Which trolley moved further? The one with the stronger push. Remember, the strength of our force can change how the object moves. Next, we have a tennis ball. What can I do to make the ball move? That's right. I can push it. Watch carefully. I used a gentle push so the ball didn't travel very far. Now I'm going to use a stronger push. Look how much further it traveled. Was my first force gentle or strong? Gentle. And what about my second force? Strong. Can everyone show me with your hands what a gentle push looks like? Amazing. And now a strong push. Fantastic. Now we're going to investigate something that we use every day, a chair. Now what happens when I push the chair? The chair moved away from me. Now, can I move the chair towards me? Yes, I can pull it towards me. So, is the chair only moved by pushing? No, we can use both a push and a pull. Shall we practice together? Go in front of your chairs. Now everyone, push. Great. Now, pull. Excellent. Which direction did the chair move when you pushed it? Away from you. And when I pulled it? Towards me. Amazing. Our final object is a box. Can I push the box? Yes. And can I pull the box? Yes. So again, we can use both a push and a pull. Now watch carefully. That was a gentle push. Now I'll use a stronger push. What did you notice? That's right. The stronger push made the box move further. Scientists, now we have seen that changing the strength of our force can change how an object moves. Let's think about what we've discovered today. A push moves something away from us, and a pull moves something towards us. And what happens when we use a stronger force? That's right, I can make an object move further or faster. Today, you were excellent force detectives. We investigated real objects and discovered that pushes and pulls are forces that can change how an object moves. Give yourselves a big scientist clap. Well done, little scientists.